Thanks everyone for stopping by the booth today. Hello to everyone on the stream. My name is Brett Morris. I'm the co-founder, co-creative director of a little studio called Ranger and Fox. We're based in LA. We've been up and running for about 18 months now. And I just want to give a huge shout out to Steve and Monica, who, without their help, obviously none of this is achievable. So we're a 3D design and animation studio. We use Cinema 4D as our main tool of choice. It's integrated into our pipeline. We tend to use some other applications every now and again, and we're constantly looking at ways to sort of expand our tool belt. We build custom tools, and it's really just anything that makes our job easier and more creative. And to introduce the presentation, I'd like to show our latest show reel. Thank you. So as a new studio, we're constantly trying to sort of establish our voice in the industry. And while we've had some success with client work and thankfully we're really busy, whenever we have a gap in our schedule, we're trying to plug that with an internal project. And that whole philosophy is just helps us sort of build on our body of work by us showing what we're capable of doing and what we love doing. So recently we had a 3-week opening in the schedule, and we decided to sort of take on one of these projects that had been brewing in the background for a little while. When we approached this project, we sort of had all of these grand ideas, but as we sort of tapped into this one thread that we'll talk about in a minute, everything sort of wrote itself. And what I'm going to be talking about today is basically the workflow that we had that allowed us to complete this project in 3 weeks, and just a lot of the little workflow tips and tricks that I like to sort of integrate into my projects that just allow us to be really flexible and nimble while we're sort of at the same time building something that's of scale. And so this project, if you haven't seen it, we'll watch it in a second. It's all based on traffic. And so as we're an LA-based studio, we face this problem that everyone else in LA faces, which is sitting in traffic. And somehow we're inspired by that. And there's obviously congestion issues, and there's no real solution in front of us at the moment. But there's some interesting technologies and future solutions that are sort of being developed. And this was just our way of contributing to that conversation, and at the same time making something pretty fun in the process.
Black. Black. Black.
All right, so the design phase was really, what sort of generated the idea, both conceptually and also visually. As we were getting into sort of figuring out what this project looked like, we were sort of iterating on ideas. We were sort of throwing everything at these frames, trying to figure out what the balance looked like, how we were sort of approaching each composition, what we're speaking visually as well as conceptually. And we sort of had this general idea that As LA once started out as a very simplistic city, we wanted to sort of represent that by a very basic structure to the highways. And as time's gone on, we've sort of faced with this problem, and that's inevitably led us to problem after problem, which inevitably has left us with this, cluster F of a highway structure. So when we were originally coming up with the idea, we sort of started on this scene first because we figured, hey, if we can't do this, there's no point in pursuing this project. So as we figured this out, everything else conceptually sort of followed along there, and it was just a matter of just ideating, trying to figure out how the typography was going to speak to the edit, how the 3D was going to complement the sequence, and we just like to ping pong back and forth and just really mold the creative as we're going. And we did this in 3 weeks, and it probably wouldn't have been possible to do this on a client project because we could just move so quickly, we had no check-ins. And so 3 weeks sounds like a pretty compressed timeline, but that's with absolutely no distractions at all. So I sort of want to talk about some of the core components that went into this project that allowed us to sort of move as quickly as we did. And each one of these sort of builds on top of the next. So by themselves, they're just unique ways of handling your workflow, but sort of combining them together allows us to build up to this really heavy scene, but it doesn't sort of slow us down in any way. We're not sort of bogged down by geometry management or anything like that. So I'm going to open up Cinema now and show you my amazing drawing skills. So approaching a project like this, we sort of want to understand what we're doing at the very beginning. And what I'm going to be talking about is basically our simple freeway system. This system was sort of built from the beginning, and it allowed us to sort of iterate through many scenes throughout the process, and we're adding complexity to this as we went on. So I wanted basically a rig that would allow myself to be flexible in the way that I was handling my freeways. I could sort of change the acuteness of the angle, I could change the direction of the road, and I originally thought about doing all of this with like a modular system with geometry, but I thought as I was sort of processing, I thought having a rig like this would give me a little bit more flexibility and not lock me into certain angles or anything like that. So the core idea behind this rig is basically to have a spline that will sort of be able to move towards the center. We'll be able to sort of wrap it in a sort of soft angle, and then it will also shoot out to the end. And we'll call this our start. And I apologize, I'm on a mouse at the moment, which is somewhat difficult. So we've got start and end. And so creating a spline like this manually would be really straightforward. But in this instance, I want to keep everything as live as possible. So I'm just going to change my color. One of the parameters that we needed was the ability to sort of extend these roads out as much as possible and also contract them to wherever we needed. So that needed to happen on both ends. And then as I was sort of processing, well, okay, I need to change this angle as well, I needed the ability to change the angle of the road as well. So I sort of figured like, hey, I can start to angle it this way, I could also angle it this way, and if I have the same ability on the start position, we're sort of starting to create like a circular sort of motion. So I thought, hey, if I lock everything to a circle, it just gives me that flexibility. And the last component to this was I wasn't sure what this angle would look like in the middle. So, at the very beginning we thought, hey, let's try right angles. But at the same time, it'd be really nice to have a really nice curvature that would sort of take us from point to point. So excuse my drawing, I'm a 3D artist, not an illustrator, and I'm on a mouse, so I feel severely handicapped at the moment. So let's start to build this rig and actually see how this all works together. With the spline pen, I just want a linear point, and I'm going to create 3 points here, and I'm going to count as I make these. So this point is going to be point 0, the middle point is going to be point 1, and the last one is point 2. And we can confirm that by coming over to the structure menu. And as we select each of these, 0 lights up. We can see where it is in world space. Likewise with point 1, likewise with point 2. So point 1, we want it dead center in the middle. And I'm just going to zero out its coordinates. So it's locked to world 0 at the moment. We only really want to affect point 0 and point 2. And to do that, we actually want to create a spline, add a null to that spline, and then lock the point of the spline to the null. And it's simply as easy as just dropping a circle spline in. I like to name everything, so I've got clear understanding of what's what in my scene. And just naming things, little things like A and B or 1 and 2, it just saves you a lot of headache when you're sort of searching through your object manager and you're really trying to track down something that you need to work with. So let's just call this A, and I'm going to turn both of these to something a little bit more friendly to look at. And on the A null, I'm going to switch the display over to a sphere, check the orientation to X, Y, and now I want to add an align to spline, drop the spline into the align to spline, and now our null is just locked to the spline. I mean, this is starting to sort of do what we needed to do, but I don't like it starting over here. I'd prefer if my 0 position was down the bottom. It's just a visual preference, and I think as I was building this, I just wanted to sort of lock everything into where the starting point was going to be fixed at. So from here, I also want to change the color of my spline. I like to do little things in my scene that just always helps me track both in the object manager, but also in the editor viewer. It just helps me track what's happening in the scene at all times. And those few extra clicks end up saving you more clicks down the line when you're sort of trying to figure out what's going on. So I'm coloring this spline red, and this helps me understand that this is a spline that I'm working with, but I don't want to actually use. And I'll show you what that looks like in a second when we sort of add another spline on top and we switch that to green. So in the spline, we're going to add a Xpresso tag. And I understand that Xpresso is not everyone's favorite topic, but believe me when I say it's really helpful. I think once you get over the initial shock of trying to track what all of the nodes do and understand the sort of data that flows between them, Xpresso is an incredibly powerful tool that saves time and really allows you to be more creative if you build rigs like this. So we're going to drop the spline in because we want to affect the points on the spline. We also need to work with the positional data from this A null. And the way we get these two nulls to talk to each other, nodes to talk to each other, is with the point node. And once this comes in, we've got some inputs that we can play with. And what we want to do firstly is connect the spline to the point node, and that's just object to object. And that allows the point node to input the data of the spline, and we can either set data coming into the point node, or we can export data that's coming through the point node with this node. So it's really versatile, and once you start using it with an iterator, it can open up even more possibilities. So the A null, we want to just expose the global position, pump that into the import path of the point node, hit this little blue checkpoint, open up the point position, and if you're watching what was happening here, the spline has now locked itself to this null. And this is really just the foundation of how this little rig was built. And we can now use the align to spline to sort of change that angle. And we're just going to repeat the process for the end point. So we're just going to duplicate this spline. Let's call this one B. Change the null to B. And just to help us see what's going on, let's just change the radius and the align to spline. And you can see that for me to sort of mess with this rig, I'm changing the radius as well as the align to spline positioning. And eventually we're going to expose those parameters on the top, so we can just use single sliders to affect everything at once. And as we've got this initial setup in Xpresso, we can just copy and paste our nodes. Let's replace this node with the B, and that's just instantly going to switch over to the B. It's exporting the positional data of the B null. And one thing I didn't point out, which I apologize, the very first point node that we looked at, by default, the point index is 0. So that's why we were affecting the first point. We now want to affect the point 2. So we just want to adjust that point index to 2. And once we connect the spline, if we'll watch over here, where our B null is sitting, the spline is just going to instantly just snap over there. So now we've got this nice little rig that we can sort of adjust. And when we turn off these circle splines, we can now just look at this sort of 3-point spline that's being controlled with the position that we've set up. So we're sort of at a good point, but we want to add that nice curvature that we were looking at before. And we can do that with CV's incredibly powerful and fundamentally just such a great tool to work with, the CV-Chamfer. And once we drop this spline in the chamfer, we've now got the ability to change parametrically the acuteness of that angle. And so we can increase this to something a little bit more visually appealing. And like I said before, let's switch this over to green. So at least now we can see in our viewport that we're looking at the correct spline. So it's just those little things that you sort of add and compound onto each other that make life a little bit easier and allows us to build something that's, not that interesting, but really powerful in this context of this project, because I had a cloner system that we're going to go into in a little bit that would just attach itself to this little rig, and we could just fluidly move around, we could iterate, we could throw more freeway systems on top of each other, and it was just all boiled down to a bunch of parameters. So let's kind of see what that looks like and jump over to our sort of pre-finished rig, and this is actually the production rig that we work with. The only thing I've done is just grouped everything into a null, and I've got some additional Xpresso tags as well as an additional control window on the null. So I'm not going to go into depth as far as like how to set the user data up, just because it's a little bit of a tedious process, but essentially what we're looking at is an A radius, which is, if I turn on our splines again, affecting the A radius. We've got the B radius, which is also affecting it. We've got the chamfer angle, which is not working for some reason. There we go. At a certain point, it's not going to work because the distance between the 2 points is less than the angle that we're trying to affect. So you can see it once we get to a certain point, it sort of stops. So we've got that as well as the A and B position. So yeah, very easily we were able to sort of iterate and try and find the correct angles for this. And in our scene, this is an actual production file that we're opening up now. This is what it looked like. Now this is sort of like the very basic level of what we were doing for this project as we were building up. Essentially, everything that we've worked with is contained to this little null here. So it's the same rig that we were just looking at there. We've got our user data exposed, the parameters are changed, and then underneath it, we've got geodeform, which is only affecting the top layer of the freeway. And this is being manipulated by a spline wrap. And the spline wrap is just simply taking the spline rig that we were working with, and it's just wrapping the geometry along it. And additionally to that, there is a geocloners, which is actually controlling the vertical structure supports. So between these two types of cloners, they're all responding to the same rig. And as we sort of change these parameters, you see that everything sort of locks itself to it. And we were able to sort of duplicate this one little island a couple of times over. And that would give us something that looked a little bit closer to an actual production scene file that had multiple freeway structures in it that we were able to sort of layer on top of each other, offset the position of these like vertical structures just within the cloner, and just to move some cameras around the scene to sort of lock up exactly what we wanted to find compositionally. And for the first maybe 10 shots of the sequence, it's all just based on this. And the only thing that we really did on top was we might have taken one of these systems and simply just dropped it into a cloner, which we can just do quickly. And removing some of these vertical structures, obviously, let's just do that so we're not overcomplicating the scene. We could just increase the cloners as much as we want and start to play with some sort of rotational control where we were sort of splicing things out, and we were getting some really nice fanning moments. And so these sorts of things were just all compounded on top of each other in a very simplistic way that allowed for like a really complex visually scene that was very easy to work with, and the whole process was just really fun trying to figure out these nice little workflow techniques. So the next sort of topic and module that we'll sort of discuss is the instances. So we were just sort of looking at the very low polygon count version of what the freeway looked like. And what I want to sort of break down is sort of this idea that we had instances compounding on instances that were all being controlled from like a master switch. And at any point in the project, we could render out high density polygons for style frames, but then we could also switch back to a proxy scene that would allow us to sort of iterate on these visual ideas. We could render out sequences for the animatic in basically real time, and never, not once throughout the process, did we feel like we were putting too much pressure on the computer to handle that amount of geometry. So the central idea is that everything is based from this one platform that we're looking at now, and the poly count that we have here is low enough that when we duplicate this out, 100x times, it's like the computer can still handle it, but we're also getting the correct deformation. So it was sort of like a balancing act to not give the geometry too much geometry, but at the same time we needed enough that our deformations looked correct. So in this version we've got like a street divider, we've got some rails, we've got some street lights, and everything that we're looking at here is just contained to this null. And you can see that we've just got a stack of materials, and this allowed us to just focus our attention on a minimal amount of assets and not sort of duplicating this, X amount of times, and everything starts to get much more crazy when you sort of iterate and spit out many variations. So the way we did handle variations, this was sort of our core object that we're working with, and then we had a series of street signs that we were working with that allowed us to add on to a different clone, and it allowed us to sort of create a lot of complexity really quickly, but everything was sort of pulling back to these single source objects. And the way we sort of approached it was having an instancing setup like this that allowed us to basically have an instance that was referencing the platform, and we could duplicate that out and accompany it with a set of highway signs. So what we're looking at here is, instancings A through to E, and each one is a little bit different, but you can see that we've got this consistent platform in every single one. And then just depending on what we wanted for each of them, we had a highway sign, so you can see this one is just the platform that we're looking at and the additional sign over here. And we've got another one down here, which was the central sort of signage that's sitting over the top. And each one of them was just slightly different, but again, it's all being derived from this one object. So in our ability to see what was going on, I could bounce between the high polygon count and the proxy version very simply with this switch here. So if I'm on frame 0, I can hit this switch and I'm just switching back to the proxy version. And for the proxy version for everything was just a very sort of uniform model to what the high density stuff was, and it allowed us to just check certain things like, hey, this is facing upwards because we've got these rails that are sort of matching up. And I might just sort of show you how that looks, just so we've got some clarity on that. So you can see between the green and the pink, everything's about the same width, the same height. The rails are sort of popping up about the same. Obviously, we don't have that additional detail, but for a low proxy version, it's enough to get us across the line. And we had the same sort of approach with the support. So this is our proxy of the support, and this is the high density version. So you can see that everything's within the same sort of world. We're not really veering too far away. Obviously, it's a much simplistic version, but it's enough that it allows us to see generally what's happening with the clones and how our scene is being built up. So I'm just going to go back to turning all this off. And the instancing setup, if you caught it, as I switch between a high and a low version, various things are happening under the hood on these Xpresso tags. So when our proxy is activated, and really all that's happening, it's just it's a null with a little bit of user data to it. There's absolutely no Xpresso on that null at all. Everything is being controlled from the instances themselves. So if we just sort of focus what's going on down here in this one, in B, I'll just close these up. When we have the control activated, so the proxy's enabled, the highway signage is turned off, and you can see that by the little cross there. And then when we turn the control checkmark off, we should have the high density polygon switch out, and then our highway sign is activated, and we can see it exactly how we want to render it. And you can see everything's been activated over here. And all that's happening is on any instance that has the highway pass or highway sign in it, I just have a little bit of Xpresso that says, hey, whatever that control null is doing, just behave this way. So really, if the proxy is on, it's going to turn all the highway signs off. And then on our platform's doing something a little bit different. In the Xpresso tag itself, we've got two link slots. We've got one for high, so we can just add in our high geometry, as well as a proxy, which loads in the proxy version. And the Xpresso is a little bit more complicated. It's looking for this master control switch that we've set up. It's got a condition that says, hey, if you're active, use this model. If you're deactivated, use this model. And that's all that's happening. And it's sending that information over into the instance itself, and it's essentially loading it into this slot here. And you can see this little icon that says Xpresso is managing it. So the reason why I like to work on Xpresso tags themselves in these sorts of cases, it allows us for quick scalability in a way that sort of, it empowers you to sort of do one little system once and just duplicate it as many times as you want, and you're not abiding by some sort of master Xpresso rig that's holding everything together. So if we create a new instance, it's an instance, there's absolutely nothing in it. We're just going to pull it over here. You can see that there's no reference object. It's got the X to say that it's doing nothing. If I just take this Xpresso null and copy it onto this instance, it instantly loads up the high polygon geometry. And that's because the Xpresso is a relative reference path. So if the tag is on the object, it just populates it to that object itself. And then again, because nothing is connected on a master scheme, we can just work with the proxy, enabling it on and off. And, oops. There we go. And then we can sort of just bounce between, whether or not these proxies are on or off. So again, it's just little things that sort of add up throughout the process that sort of enable you to sort of have the ability to shift over style frames where you want to look at your geometry, and at the same time you sort of peel back into more of a pipeline where you can sort of work really quickly and efficiently. Okay, so the next sort of component that we're going to look at is what we called the cluster spline. And I mentioned this was sort of the first element that we looked at when we were getting this project off the ground. And to us, we knew that if we didn't have the ability to figure this scene out, this whole project wouldn't work. So I'm just going to relink my Alembic up for a second. So we generated this spline in Houdini, and it doesn't look pretty in any way, but it was a great starting point for us to figure out how this form was going to work and what our pipeline looked like, essentially. So once we had it, I think we were pretty happy with generally what was happening, even though what we're looking at now is pretty chaotic. And on closer inspection, we sort of realized that what we were dealing with in Cinema was not exactly what we wanted, because we have way too many of these kinks coming through, and we just felt that it was just easier for us to handle this problem inside Cinema than going back and forth. So at this point, we needed to smooth things out because the geometry would behave in a really funky way if we ran this along the spline. And to clean it up, we had a MoSpline, which all I've done to this one is set the mode to spline so we can add in a new spline. And we've added in that Alembic file that we imported. And we've got the generation mode to even and the count to 500. So essentially what's happening, the MoSpline's looking at the object that is being imported. It's redistributing 500 points along it. And you can start to see that we can incrementally add in more detail or less detail based on what we desire. And if I drop this down to, say, 100, you can see that it gets way more sparse, and it's probably going to work for sort of the more wider acute angles. But then once we get sort of into this intersection over here, there's just simply not enough detail for us to capture any of it. So we want to retain the integrity of what we had set up. So 500 was a good sort of number because it still allowed us to catch, all of these different curvatures. So at this point, it's not really helpful, and the way we sort of keep pushing it into cinema is if we duplicate the MoSpline, make it editable, and I'm going to turn these off so we're only looking at this new spline that we created. Just switch over the color to white, just so we can see it. And now if we press play, nothing's happening, and we've got absolutely no link between MoSpline or the Alembic file. The first thing we want to do now that we've got this as a spline, we just want to set the type to cubic, and that allows us to get that nice smooth flowback. And within MoSpline, not only can it import spline data and then manipulate it into a new spline, it can also export out that data as well. And you do this by switching over to the Object tab, and you've got this destination spline. And because we just duplicated this MoSpline, we have the same amount of points. And if we drop in our static spline that we're currently looking at into the destination spline, we've now taken all of that point level animation that we're looking at the Alembic file. We're resampling the points, and then we're transferring that point animation over to our new spline. And again, we're looking at the new spline we created, and we can press play, and we've retained all of that animation. And if we turn back on the original Alembic file, you can see that the integrity is still there, but we've cleaned up all the spline. And this just allowed us to have a really nice clean deformation when we were sort of adding all of these freeways and a ton of geometry on top. So we got to this point and realized that the amount of speed in that animation was not what we were after. So we sort of took everything, threw it out, and started all over again with that bake spline that we were sort of looking at just a moment ago. So we're sort of looking at a static spline again, and the goal here was sort of to add more weight into the animation. If you think of this giant, enormous structure, it's probably like 3 or 4 miles wide, and with that amount of animation, everything would just feel a little bit too light and really too unrealistic for a somewhat unrealistic scene. So we wanted to sort of ground it a little bit and add a little bit more weight to everything. And we simply did that by adding a spline dynamics tag to the spline itself. Over in forces, just drop the gravity down to 0, add turbulence modifier into the forces tab. And once that turbulence is turned on, we then had an additional layer of animation that we could add into the mix. And you can see once we get up close with it, we've just got that extra layer of animation that, when you see this in context, it felt way more correct than how it was feeling before. So from here, once we were happy with that, we then wanted to bake out this file as an Alembic file. And I'm just relinking this for a moment. So basically what we would do is select this file, this object, come over to export Alembic, and we'd save the file out. In R20, there's a great new feature where you can actually just do this from the object itself. It's sitting around here. I'm doing this in R19. We didn't have access to R20 when we did this project, so little things like that I think are going to make this process even more simplistic. But once we've got our animation baked, it gives us the ability to sort of scrub backwards and forwards, and we're not relying on that live simulation that's happening, and we can take a lot of the processing off the computer as we're sort of going into the next stage. Once we have the spline baked, we sort of faced with another challenge, and I'm going to zoom in over here, which we can see a little cube. It's actually a yellow cube, but there's so many subdivisions that we needed to be actually able to form this. So once I turn this spline wrap on, the geometry, sorry, I just revealed my trick. So the geometry is kind of like a little bit funky. There's no cohesiveness to the angle. And if we were looking at the geometry itself, with the structure geometry, we'd have these like giant structures pointing outwards, and it would just not look correct. So we need everything to point inwards. And so we needed to create a rail in doing that. So we just went through that simple MoSpline technique again, where we would have the mode set to spline, we'd have our source spline, we'd add our Alembic file, and then when we turn this MoSpline on, we've got, let me just turn this turbulence off. We've got this enormous spline around it. Now what's happening is we're actually scaling it up a factor of 100. And what that's doing, it's saying, hey, all of the tangents, the normals of all the points, just point to your correlative point on this rail. And so when we add the rail into the spline wrap, you'll see very quickly that everything starts to feel a little bit more normal. So again, it's just little things like that with the MoSpline that allows you to sort of move between challenges that you're faced with working with splines. And I think the sort of MoSpline as well as the Connect object are sort of the best get out of jail free cards that we've got in Cinema. And so I sort of wanted to show a couple of those techniques that we used to sort of figure out how this scene was going to work. And then once we were over in our production file, this is sort of a combination of everything that we've been looking at up until now. You know, we're obviously not looking at the Freeway Rig that we built, but we're looking at the Alembic file that we just baked out. We've got the exact same cloner structure that we had before. So everything that we were looking at with the instancing is all in here. We've got the cloner geo stuff, which is all of the supports on the cars. We've got the correct rail. All of the support is pointing inwards. And I'm somewhat reluctant to do this live, but I'm going to turn the proxies off, and we'll see what this looks like with the full geometry. Depending on what your system's like, obviously you can push it as hard as you want, but there is a certain limitation that the computer just might not have enough RAM, or the processors are not up to scratch. And I think we'll have some success. Yeah. So this is what everything looked like when we have everything turned on, and I might just show sort of how much geometry we're dealing with in here. It's it's a pretty heavy scene, but we were working in a way that allowed us not to rely on looking at everything that we're seeing currently. We could just look at the proxies and we could move forward, and only at render time would we turn everything off with one button, hit render, and we knew everything would look correct. The last component that I wanted to talk about in this presentation is Redshift. We adopted Redshift a little while ago, and it was purely on the basis that we had more capabilities with the shaders that sort of spoke to our needs as a studio. And we've been sort of chipping away at sort of, understanding it a little bit more, and as it's developing, we're sort of growing with it. And this was the first time that we'd actually used proxies in production. Now, we were really happy with the idea of having proxies, but it wasn't until we discovered this thing that I'm going to show you today that really solidified this decision to move into Redshift, because it really saved us a lot of processing, and it's a really cool little feature that it has. So I'm going to bounce over to our last scene. In our final scene, we've got a couple of shots that have maybe upwards of like 1,000 cars. There's just tons of cars flying around. They're all different types. We've got a very subtle sort of color shift from car to car, and we created all of that within this scene that we're working with here. There's this one checkbox that sort of opened up all of these possibilities. And so we're going to sort of walk through how we approached it and how it helped us in production. So the project, we had about 10 different cars, which you can see in our layer here. We're just looking at the Honda Civic for now. We're just going to open up a Redshift renderer, and we'll just get a little render going over here. So every car that we had was actually just a Redshift car paint shader, and everything was abiding by the same materials that we've got down the bottom. So we just created a base car paint shader, and Redshift's just going to show us that we just created a red shader. Once we come into the shader graph, what we wanted to think about is how do we add color variation into our render, but allows us to not create tons of geometry, or at least create, a different bit of geometry for every different color car that we wanted to have. And so if you don't like Xpresso, you're probably not going to like Redshift, but trust me, if you learn the nodes, it's really powerful, and it's really a fun way to work in production. And with R20's material node shader, I think everyone's going to adopt it very quickly because it is very powerful. But at least this way you can kind of tiptoe in without being super intimidated by what it can do. So what we basically want to do is assign an attribute to each of our models. And we do that by using some user data that we can create with Redshift. And we're just going to create this Redshift user color data. And if we open up this little tab over here, it gives us a couple of different options, predefined options that are going to talk to Cinema off the bat. And if we create a MoGraph color, this is essentially when you've got a cloner and you've got different colors on all of them. That displayed color is a randomized value on every different clone. And so we're going to utilize that effect into our shader here. And essentially what we want to do is take that random color and remap it over a color gradient that we want to set for it. And we do that by adding a ramp into the mix. We want to connect the color user data into the ramp, just with the general input. Most importantly, we want to switch the source over to alt. And then when we connect this ramp over to our base layer diffuse color, we've now connected everything together, but we're not going to see any result because we haven't committed this bit of geometry to a cloner. We have no randomness, but you can see that the color changed here in the viewport because it's essentially using just a default color coming through this ramp to affect everything. So for the presentation, let's just do something a little bit more bright and vivid than what we had in the final spot. So I'm just going to sort of open this up a little bit. Going to just add a couple of colors that, are clearly unique and a little bit different from each other. Maybe just one more as well. So now that we've got this, we're going to see a little bit of an update. Now it's just picking up that first cyan color that we had in. And if we drop the object into the cloner now and turn it on, just pull the camera out a little bit, all of our clones have essentially the same color as that we're looking at now. It's just this nice cyan one. So when we activate the color random, which I've already added in, now nothing exciting is happening in it. All we're doing is turning off all the default parameters, and we're just turning this color mode to on. That's all we need to do to add random color into our clones. And once we turn on the effector, once Redshift has a moment to think about it, it's going to basically look at the color random that is assigned to each node. It's going to change the color value into each clone and only affect it on that material level. So we've sort of got these, the ability to sort of do these in multi-shaders and color shaders and all that currently. But where this gets a little bit powerful is where the next stage of this process. So consider everything that we've looked at now all very doable, and it's all very, accessible to the tools that we've got. So when we create a proxy, which we do by selecting the object, I'm just going to pull it out of the cloner in case something goes funny. Let's just select it. We come over here, export out a Redshift proxy. I'm just going to send the file here. I'll just say save. Now we've got some parameters that we can select. We just want to export selected objects. We've got lights. We don't need lights for this. We want to compress the data, and we also want to say add proxy to scene. So just by clicking this, Redshift's just going to basically bake down all the geometry. If we've got lights in there, it's going to collapse the lights, bake it in as well. It's going to collect all the materials. It's going to put it in this nice, neat little package that Redshift speaks to. And we're left with this object that was imported that we're looking at here, which if I turn off our Civic, it's just a nice little skeleton of the box. This just gives us an idea of how big the mesh is that we're working with, that we just saved out. And on the preview, we can switch it to a bounding box if we need to see what the intersections are happening with the object. We can also access the mesh if we're looking at composition. So cool, all right. We can do this in Xrefs. We can do all the color shaders already. Where I found this to be really powerful is if I copy the cloner, the Redshift proxy, as well as the random effector into a new scene. Let's just switch this over to box, or just off actually, and put the proxy in the cloner. we can see that the clone is doing essentially what we were looking at before. We're just looking at a nice little box of everything. We still have the ability to see the mesh if we need to. But if we render, we're going to see all of the default sort of cyan colors. Even if we turn on the random color, nothing is going to change. So in the proxy itself, we've got this extra little tab down here for the overrides. And this allows us to tap into the proxy itself, activate some of the parameters, and send some of that information back into Cinema. So we've got this nice little checkbox down here called user data. And once we activate this, you can see now that we're transferring that color information that we have in the material into our file. So this allowed us to basically create 10 different cars that had this particular material assigned to it. When we brought it into our master file, we never needed to even turn on anything like this. We could populate a scene with like 1,000 cars, never put any pressure on Cinema, and then at render time, Redshift would just dive into those proxies, pull all the information into the render itself, load up all of the material offset in color via the user data, and we'd be able to render frames that had 1,000 plus cars in about a minute, minute and a half, and at not one point in the process were we ever hurting or needed to backtrack for any reason. And that pretty much wraps it up. So I want to thank everyone for stopping by. I really hope you've enjoyed the presentation. I just want to run through the project one more time, and hopefully you can kind of pick out some of the techniques that we had and see how this project was done in 3 weeks. Thank you again.
Black. 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 Black.